Marie Curie, a name synonymous with scientific excellence and perseverance, was a trailblazer in the fields of chemistry and physics. As the first woman to win a Nobel Prize and the only individual to receive Nobel Prizes in two distinct scientific disciplines, her groundbreaking work on radioactivity transformed scientific understanding and medical practices. Born in Poland and later becoming a naturalized French citizen, Curie faced numerous challenges, including societal norms and personal tragedies. Yet, her relentless pursuit of knowledge and commitment to scientific inquiry paved the way for countless women in science and established her as a pivotal figure in history. This essay delves into the life and achievements of Marie Curie, exploring her early life, significant scientific contributions, the challenges she faced, and her enduring legacy. Maria Skłodowska was born on November 7, 1867, in Warsaw, Poland, into a family of educators. Her father, Władysław Skłodowski, was a teacher of physics and mathematics, while her mother, Bronisława, ran a boarding school for girls. The Skłodowski family placed a strong emphasis on education, which profoundly influenced Marie's early life. However, her childhood was marred by the political turmoil in Poland, as the country was partitioned and divided among Russia, Prussia, and Austria. Despite these challenges, Marie excelled in her studies. Her family faced financial difficulties after her mother's death from tuberculosis in 1878, but Marie remained determined to pursue her education. The limited opportunities for women in Poland, particularly in the sciences, fueled her desire to seek knowledge elsewhere. In 1890, seeking higher education, Curie moved to Paris, where she enrolled at the Sorbonne. The transition was challenging. She faced cultural differences, financial constraints, and the loneliness of being away from her family. Nevertheless, her dedication to her studies paid off. She earned degrees in physics and mathematics in 1893 and 1894, respectively. Her exceptional academic performance garnered recognition, setting the stage for her future contributions to science. While in Paris, Curie was exposed to the vibrant intellectual climate of the time, which included the works of prominent scientists like Henri Becquerel, who discovered radioactivity. This new field of study captivated her, and she began to focus her research on the properties of radioactive materials. Curie's scientific career began in earnest when she joined Henri Becquerel's laboratory at the École de Physique at de Chimie. Her research focused on the mysterious rays emitted by uranium, which Becquerel had recently discovered. Curie's initial investigations led her to hypothesize that the intensity of these rays was related to the amount of uranium present. Curie's systematic study of uranium led her to discover that pitchblende, a mineral containing uranium, emitted even stronger rays. This finding prompted her to explore the properties of other elements, leading to a groundbreaking realization. Some materials contained an inherent radioactivity that could not be explained by the presence of uranium alone. In 1898, Marie Curie and her husband, Pierre Curie, embarked on a quest to isolate new radioactive elements from pitchblende. Their labor-intensive work involved processing tons of the mineral to extract minute quantities of the desired elements. In July 1898, they announced the discovery of a new element, which Curie named polonium in honor of her native Poland. Later that year, they identified another element, radium, which emitted even stronger radioactivity. The isolation of radium was particularly significant, as it exhibited remarkable properties that fascinated scientists and medical practitioners alike. Curie's meticulous work not only led to the identification of these elements but also established her as a prominent figure in the scientific community. Marie Curie's groundbreaking contributions to the field of radioactivity did not go unnoticed. In 1903, she was awarded the Nobel Prize in Physics, shared with Pierre Curie and Henri Becquerel. This recognition marked a monumental achievement, as she became the first woman to receive a Nobel Prize. The award acknowledged not only the Curie's scientific endeavors but also the transformative impact of their research on the understanding of atomic structure and radioactivity. The Nobel Prize brought Curie international acclaim, but it also posed new challenges. The media attention and public scrutiny intensified, yet she remained focused on her research, determined to contribute further to the scientific community. In 1911, Curie was awarded her second Nobel Prize, this time in chemistry, for her isolation of radium and polonium and her study of their properties. This achievement solidified her status as a pioneering scientist and underscored her exceptional contributions to both physics and chemistry. Curie's second Nobel Prize made her the only person to have received Nobel Prizes in two different scientific disciplines, a testament to her versatility and brilliance. Despite her accolades, Curie remained humble, often emphasizing the collaborative nature of scientific discovery. She continued to push the boundaries of knowledge in radioactivity, laying the groundwork for future research. Throughout her career, Marie Curie faced significant challenges as a woman in a male-dominated field. The scientific community was largely resistant to female participation, and many of her contemporaries were skeptical of women's capabilities in scientific research. Curie often had to navigate gender biases and discrimination, fighting to be recognized as a legitimate scientist rather than merely the wife of Pierre Curie. Despite these obstacles, Curie persevered. She became a strong advocate for women in science, paving the way for future generations. Her achievements challenged societal norms and inspired women to pursue careers in STEM fields. The sudden death of Pierre Curie in 1906 profoundly affected Marie's life and work. He was not only her husband but also her collaborator and support system. Following his passing, Curie took on the leadership of their laboratory, determined to continue their shared vision of scientific inquiry. Amidst her personal grief, she also faced the challenges of raising two daughters, Irene and Eve. Curie balanced her responsibilities as a mother with her commitment to research, demonstrating remarkable resilience in the face of adversity. One of Curie's most significant contributions was the application of radium in medicine. She recognized the potential of radioactive materials in treating cancer, particularly in targeting malignant cells. Her research laid the foundation for the development of radiation therapy, a vital tool in modern medicine. Curie's dedication to advancing medical science extended beyond her research. She actively promoted the use of radium in clinical settings, advocating for its acceptance as a legitimate treatment option. Her work contributed to the early understanding of cancer treatment and established radioactivity as a critical area of study in medicine. During World War I, Curie's contributions took on new significance. Recognizing the need for medical advancements on the battlefield, she developed mobile X-ray units, known as Little Curies, to assist in the diagnosis and treatment of injuries. Curie trained medical personnel to operate these units, providing critical support to injured soldiers and saving countless lives. Her efforts during the war demonstrated not only her scientific ingenuity but also her unwavering commitment to humanitarian causes. Curie's work in medical technology during this period exemplified her belief in using science for the greater good. After the war, Curie continued her research in radioactivity, focusing on its implications for health and safety. She became increasingly aware of the dangers associated with prolonged exposure to radiation, advocating for regulations and safety measures in laboratories and medical facilities. Curie's dedication to scientific inquiry remained unwavering, and she continued to publish research papers and mentor young scientists. Her commitment to education and knowledge sharing helped foster a new generation of researchers. Marie Curie passed away on July 4, 1934, from aplastic anemia, a condition likely caused by her prolonged exposure to radiation. Her death marked the loss of a pioneering scientist whose contributions had transformed multiple fields of study. In recognition of her groundbreaking work, numerous institutions and scholarships have been named in her honor. Curie's legacy continues to influence science and society. She is remembered not only for her scientific achievements but also for her role as a trailblazer for women in the sciences. Her life story inspires countless individuals, reminding them of the importance of perseverance, curiosity, and commitment to knowledge. Marie Curie's groundbreaking achievements have had a profound impact on women in science. Her success challenged traditional gender roles and inspired generations of women to pursue careers in STEM fields. Curie's story serves as a reminder that with determination and resilience, barriers can be broken, and dreams can be realized. Numerous organizations and initiatives have been established in Curie's honor, aimed at supporting women in science and promoting gender equality in research and education. Her legacy continues to inspire aspiring female scientists, encouraging them to pursue their passions despite societal challenges. Curie's discoveries in radioactivity laid the groundwork for ongoing research in nuclear physics and medicine. Her work has had far-reaching implications, influencing advancements in cancer treatment, medical imaging, and nuclear technology. The field of radioactivity continues to evolve, with scientists building upon Curie's findings to explore new applications and safety measures. Her legacy serves as a foundation for ongoing research and innovation, ensuring that her contributions to science remain relevant in contemporary discussions. Marie Curie's life and work embody the spirit of scientific inquiry and perseverance. As a pioneer in radioactivity, she broke barriers, challenged societal norms, and made groundbreaking contributions to chemistry and physics. Her achievements not only advanced scientific understanding but also paved the way for future generations of women in science. Curie's legacy continues to inspire individuals worldwide, reminding us of the power of knowledge, determination, and the pursuit of excellence. As we celebrate her contributions, we honor not only her achievements but also the profound impact she has had on science, society, and the fight for gender equality.